Welcome student, we are talking about general chemistry CH15012 and today we are going to discuss the dry test for cation and anions. Dry test for positive radicals. As already we have discussed in our previous presentation, for dry test, all tests done using the dry powder given to you, and your test tube must be moisture free. You need to take a dry test tube for this, and please do not use any solvent, any kind of solvent for this test. And for that you need to take a test tube, add 10 to 100 milligram approx substance because we are performing semi micro method, and then we need to heat it at the bottom of the test tube, the substance, and then we need to see the observation. Now what kind of observations are there for heating test in a dry test tube? So generally you need to write in this form. A 3-column system would be there. First is of test column, then observation, and then inference. In a test column, our test we need to write heating in a dry test tube. Take a compound in a dry test tube and heat. 6 observations are there. First one, substance melts or substance does not melt. If substance melts, we can write in inference that crystalline salt of Na plus, K plus, NH4 plus and soluble salts of chloride, bromide, iodide, sulfate, nitrate may be present. If substance does not melt, then these are absent. Instead, we can write carbonate, sulfide, phosphate oxide may be present. If water deposit on cooler part of the test tube, then we should write the hydride or hydroxide salt of Na plus, K plus, NH4 plus, hydride, hydroxide, chloride, bromide, iodide, etc. may be present. And if water will not deposit on the cooler part of the test tube on heating, we can mention these radicals are absent. Now decrepiting sound occurs or not. If the decrepiting sound during heating the substance in a dry test tube occurs, we may say that salt of nitrates are there. Especially lead nitrate create loud sound on heating in a test tube, dry test tube. So nitrate may be present. If the decrepiting sound would not be there, we may write that salts of nitrates are absent. Fourth observation of the same test is the sublimation occurs or not. Sublimation, that is a situation in which the solid turns into a vapor or a gaseous form and it will deposit on the cooler part of the test tube. If the sublimation occurs, we need to perform charcoal test. We will discuss on it. If sublimation does not occur, then those sublimating elements are absent. Suppose sublimation occurs, we can write that salts of ammonia, antimony, arsenic, iodide may be present. If we've got the sublimation, then again we need to take a new test tube, add charcoal powder, sodium carbonate in it and your substance and heat again. And then you need to see the observation whether the black mirror or a garlic smell or different type of vapor coming out of it or not. In doing so, we can identify these elements from each other. Iodine, when turns into vapor, means sublimes, it will give violet fumes. Arsenic gives garlic smell. Antimony form a mirror effect on the side of the test tube, and ammonia gives smell of ammonia, which you can identify by putting a glass rod dipped into HCl on it. If you get white fumes, you may say that coming gas is ammonia. So that way, performing charcoal test, you can identify these elements from each other. Then after, next is the gas evolution. We need to check whether the colored or colorless gas evolution on heating the substance in a dry test tube occurs or not. If it is color, what color, by which we can identify the negative ion of the compound, anion of the compound. or if colorless, then by performing certain other more tests we can identify the colorless gas as well. But ideally, if you do not recognize anything, then it would be safest to write no gas evolution, gaseous elements are absent. Now as far as color change in the residue is concerned, we need to take two type of observation. During when the test tube is hot, what should be the color of the residue, and when we cool the test tube, what should be the color of the compound in it. If both are colorless, then salts of aluminium, barium, strontium, calcium, sodium, potassium, ammonium, manganese, zinc may be present. And if colored compound would be there, then we will going to get some black during hot and during cold, black color. Then nickel, cobalt, iron, this kind of colored elements would be there. Chromium, this kind of color element would be there. If during hot, yellow, during cold, colorless, there should be zinc. So zinc you cannot put into colorless, but in certain cases, if you, because the color yellow color is very pale, fainted yellow color, you cannot recognize, and therefore it is mentioned over here. Otherwise, during hot, if it is yellow, and during cold, colorless, then there should be zinc. So that way 6 observation of a single test you may do. Let's see how this test can be observed. Number 1, for the observation, when you are going to heat the substance, you need to know whether the substance melts or not. Crystalline substance will melt, amorphous substance won't. And when substance melt and you revert the test tube, it will stuck on the bottom. Then we can say that substance does melt. And if the substance won't stuck at the bottom, you can say that substance does not melt. So that way you can take your observation number 1. Observation 3. Water deposit on the cooler part of the test tube. On heating the compound, if water droplets come at the cooler part of the test tube, you may say hydride salts are present, and if crystal water will going to deposit over here. So mostly crystalline substance on heating give you water droplet at the cooler part of the test tube. Third, sublimation take place if the gas ammonia will come out, and if you are going to put a stirrer dipped into HCl, and if you notice this kind of white fumes coming out of the stirrer itself, then you can say that coming gas is of ammonia. And for colorless gas evolution, if the gas we will pass through another test tube which contain lime water, and if that lime water turn milky, we can say that colorless gas is ammonia. That way, if you can smell the compound, but we will not going to advise you to smell, but if you want to smell, you can wave your hand like this and push the fumes to the nose rather than keep your nose on the mouth of the test tube. That way you can smell the compound. And at the end, residue change. If the colorless residue is there, or during hot and during cold, you can say calcium, strontium, barium, magnesium, aluminium, this kind of salts, cation containing salts would be there. If during hot, yellow, and during cold, white, then that would be zinc. And if the residue color is black, it would be always a colored element like iron, nickel, chromium, manganese, etc. Do not smell the compound directly. It is strictly prohibited. So 6 observation is there for the first test. Now we need to perform the second test, that is a flame test. As you know, this is the preparation required for flame test. You required one platinum wire. That platinum wire you can loop with the help of a pencil. So a loop is created at the end of the platinum wire. Take a watch glass, add HCl and compound in it and create a paste of it. Keep that paste into the loop and apply it into the flame, and then observe different observation. If you found stable golden yellow flame, you may say that in the inference that is sodium present. If you found pinkish violet flame, it should be potassium. If apple green flame is going to be observed, that is barium plus 2. Brick red color, that is calcium plus 2. Crimson red color flame, then it will be strontium plus 2, and bluish green flame will give you a copper. Copper is the only colored element which gives flame. Rest element, colored element won't give you flame. And if your compound is colorless, then it is ideal to perform a flame test. Well, the chloride of several metal impart characteristic color to the flame because they are volatile in non-luminous flame. This test is performed with the help of platinum wire. You need to create a tiny loop. Already I have suggested at the one end of the platinum wire. To clean the loop, dip it into concentrated hydrochloric acid and hold it into the flame, non-luminous flame. Then repeat again and clean the platinum wire. Then you need to take 2-3 drop of concentrated hydrochloric acid on a clean watch glass and make a paste of small quantity of the salt in it. Dip your clean loop of platinum wire into the paste and introduce loop into the non-luminous or oxidizing flame, and then you observe different color. You may found this kind of different observation there. Stable golden yellow, Na plus is there. Pinkish violet, that is potassium. Apple green like this one, it is barium. Crimson red, it is strontium, and when you apply a cobalt glass, this crimson red will looks like violet. Brick red color, that is of calcium, and bluish green, that is copper. Except this, some other elements are there like rubidium, cesium, lithium, technetium. These all elements will going to give flame, but this much is there in our syllabus, that's why this many is mentioned over here. Next is a borax bead test. This test is employed only on colored salt because borax react with a metal salt to form a metal borate or metal metaborite which have characteristic color. To perform this test, make a loop at the end of the platinum wire and heat it in the flame till it is red hot. Dip this red hot loop into borax powder and heat it again. Borax forms a colorless transparent bead on the loop. Before dipping the borax bead into the test salt or the mixture of the compound, confirm that bead is transparent and colorless. If it is colored, this means that there should be a contamination. The platinum wire is not clear and therefore you are not getting a good observation. Dip the bead in a small quantity of your dry salt and hold it into the flame. Observe the color imparted on the bead in the non-luminous flame as well as in the luminous flame while it is hot and while it is cold. To remove the bead from the platinum wire, heat it to redness and tap the platinum wire with your finger. If you found these observations, you can identify this colored element in the oxidizing flame, which we need to take the observation. We will never going to take observation into luminous flame or a reducing flame. In oxidizing flame, in cold and hot, if you have blue or green color, we can recognize that that compound would be copper. The bead color would be reddish brown or violet, it would be nica. The bead color would be light violet or light violet both in cold and hot. We're going to get a manganese, and if it is turning yellow or brownish yellow, it would be ferric. Now generally in borax bead test what happen, we have a borax powder with a molecular formula, boric anhydride, boric powder, that is Na2B4O7.10H2O, sodium borate decahydrate. On heating it will convert it into sodium metaborate Na2B4O7, and water molecule will evolve out. Na2B4O7 on heating gives sodium metaborate, that is NaBO2, and boric anhydride, that is B2O3. Then that B2O3, that is boric anhydride, when we add into any compound, the compound is going to form metal metaborate, and that metal metaborate have different color, and on the base of that we can identify the element, colored element of the compound, especially cations. Now sodium hydroxide test, that is test number 4 in the dry test of cation, and that is the last test for the dry test of cation. For that we need to take a compound, add sodium hydroxide in it and heat a little bit. If it evolved ammonia, which gives white fumes with the HCl dipped glass rod, we can confirm that the coming gas is ammonia and NH4 plus may be present. If there is no evolution of ammonia, NH4 plus may be absent. So here you can see that the coming gas, if ammonia, then a stirrer dipped into HCl will going to give you white fumes. If you are not satisfied with this observation, you can heat the compound with NaOH and put red litmus paper on the mouth of the test tube, and if your red litmus turns blue, then it would be ammonia. Ammonia would be present. If white fumes does not form on HCl dipped glass rod, then ammonia must be absent. Now we need to discuss the dry test of negative radicals. 8 tests are there. Out of 8, this 4 test is represented over here. Test number 1, that is substance plus dilute HCl. It has 2 observations. Affordances of CO2 which turns lime water milky, then we can say carbonate may be present. And if rotten egg like smell which turns lead acetate paper silvery black, then we may say that the compound should have sulfide. And as you know that carbonate and sulfide amorphous compound have, so for water soluble salt this observation could not be obtained. So that you need to keep into mind. This test can be performed for amorphous compound, and if affordances will come out, we can say that carbonate may be present, and if rotten egg like smell turns lead acetate paper silvery black, then it would be sulfide. Second test is a substance plus concentrated H2SO4 and heat. 4 observations are there. A colorless gas evolution which gives white fumes with the glass rod dipped into ammonia, then it may be chloride. If a brown red gas evolved turns starch paper yellow, it may be bromide. Violet gas evolved, red yellow gas evolved and no effect on the starch paper, nitrate would be there. And violet gas evolved and turns starch added paper blue, then it would be iodine. So 4 observation is there, and the same test is there, substance plus MnO2 plus concentrated H2SO4 and heat. If you have any doubt in this observation, using catalyst MnO2 you can perform this test, and the same observation with more intensity, more clarity you can observe, and you can say whether out of this 4 element anyone would be present or not. The fourth test is substance plus copper foil plus concentrated H2SO4. This is a special test for nitrate. Red yellow gas evolved and no effect on the starch paper, nitrate would be present. As far as this affordances is concerned, you want to see whether how lime water turn milky. You can take a test tube, add a straw like this, and you can blow. Your blow contain carbon dioxide will go into this lime water, that is calcium hydroxide, and when it turns white precipitate like calcium hydroxide is going to form calcium carbonate, it turns milky. So that observation is this one. When you have got affordances of CO2, you can convert that into lime water and you get that milky. We're going to see that observation again as well. So here are the observation for the dry test of negative radical. The first one is effervescence. You can see this kind of bubbles coming out of it when you have a compound and you add dilute HCl in it. You get this effervescence, this kind of small bubbles in your test tube. Then it is carbonate, and to confirm that carbonate, you need to take that compound again, add dilute HCl in it and heat a little bit and transfer the gas using this U tube into another test tube which have calcium lime water, that is calcium hydroxide in it. When the gas passing through this tube and enter into calcium hydroxide, and it's going to form calcium carbonate which is insoluble, and the solution turns whitish milky, and that way we can confirm that the bubble is of carbonate. So that is the first observation. In the second observation, if you have a compound, you have added a dilute HCl in it and you are going to heat it, and in the fume, if you will put a starch paper, and if your starch paper turns silvery black, then it would be sulfide and it gives rotten egg like smell. In the third observation for the chloride, compound plus concentrated H2SO4, if a colorless gas is coming and you have hang a stirrer glass rod dipped into ammonia, you observe white fumes coming out of the stirrer itself, then you may say that the coming gas is chloride. If you have any confusion in this observation, you can hold a blue litmus paper on the mouth of the test tube, adding compound plus concentrated H2SO4. If the colorless gas touch to the litmus paper and turn it red, then it is chloride. Another confirmation is there, if the gas where you will put a colored cotton cloth and if you found some spot on it, color denatured, then bleaching effect is going to be observed. That is also a confirmation of chloride. Another, that is a bromide. If you have a test tube, you have bromide compound and you have added concentrated H2SO4 in it, and if you heat it, if the coming gas is red brown in nature and which can turn the starch paper yellow, then coming gas is bromine. And finally, if you add compound plus concentrated H2SO4, you got red brown, this kind of gas evolution. Then it is brown fumes of nitrogen, and to confirm it, you may hang a starch paper on it. If there is no effect on starch paper, then this brownish red gas is of nitrate, and then you may perform the ring test. Ring test, for which you can take a compound and add it into concentrated H2SO4, and gradually you need to add FeSO4, slanting the solution. You need to add H2SO4, FeSO4 and your compound, and then H2SO4 has more gravity, so it will settle down at the bottom, and when it touch to the solution of compound and FeSO4, it will going to form a brownish ring of NO. And on the base of that, you can identify that the brown gas which is evolved from this test tube would be nitrite. And for iodide, a violet gas is there, so no need to do some extra test for that. Then after further for test number 5, that is a phosphate test. For that you need to take a substance, concentrated HNO3 and ammonium molybdenate into excess, and then you need to heat a little bit. If you get yellow canary precipitate like this one, then you may say that phosphate is present in it. Next one is the substance plus H2O. If the compound is soluble in water and if the solution turns yellow, either orange, on the base of that, if it is yellow, you can say chromate may be present, and if it is orange, you may say dichromate is present, like this one. Yellow color, that is chromate, orange, that is dichromate. Then compound plus H2O plus BaCl2, and if you get white precipitate like this one, you may say that sulfate is present. And if you have oxide which is insoluble amorphous compound, and if you won't get any radical from the above test, you may say that the compound contain oxide. And for that, substance plus H2O plus concentrated HNO3, if compound gets soluble, you may say that the compound contain oxide. After performing dry test for cation and dry test for anion, you need to give a dry test result. Stating that from the above dry test, we may conclude that the given unknown inorganic compound may contain cation, any cation, K plus, say for example, may be present, and anion, say for example, Br minus may be present. So this is the dry test analysis of inorganic compound. Thank you very much for paying attention to this video lecture. Asking question is a beautiful way to gain knowledge. So please ask question either in the chat box or through email.